Page 5 of Transformations Addendum. Number 3, copy the following graphs for y equals f of x, and on the same axes graph y equals 1 over f of x. Okay, so let's take A first. So remember that any point at y equals plus 1 or minus 1 is invariant or does not change. So we know that this middle point here stays where it is. Any y value that is greater than 1 is going to transform to a number between 0 and 1. So this graph here is going to get smaller and approach 0. Okay? And then you notice that it kind of looks like this side of the graph, right? This side is going to do the opposite. Since we are varying between the values 0 and 1 here, we're going to go from 1 to infinity here. So the closer we get to 0, that's the closer you get to infinity. So you're going to get this effect here. And actually, if you think about it, y equals f of x looks like an exponential graph, right? Like y equals 2x or something, 2 to the x or something like that. An exponential graph, when you invert it, just kind of reverses the direction. Like if this was 2 to the x, the graph of 2 to the x, and we want to see what the graph of 1 over 2 to the x looks like. Remember that 1 over 2 to the x is equal to 2 to the negative x, and 2 to the negative x is just a reflection about the y-axis. So you just reverse the direction. Okay? Let's move on to C. So in C, let's mark the places that y equals plus 1 or minus 1. Those would be invariant points. This would be y equals negative 1 here. Y equals plus 1 is the asymptote, so it approaches it but doesn't actually reach it. The vertical asymptote, on the other hand, infinity, that's when the inverse, or the reciprocal function would become 0. And when the original function becomes 0, that is when the reciprocal function has an asymptote. So with all the restrictions I created, like I created a vertical asymptote here, I kind of created a horizontal asymptote here because I know that it approaches 1 but never touches it. I've created a x-intercept here, and I've created a invariant point here. So if I trace a curve through all of these characteristics, I end up with a hyperbola going kind of in the opposite direction. Okay, but still a hyperbola. Interesting, huh? 5h, the modulus function. The modulus function is just the absolute value function. Let's see what happens when you put the absolute value function inside the parentheses of f of x. Think about it. If I have f of a positive number, like f of 3, putting the absolute value around the 3 does nothing. Okay, no change. If I have f of a negative number, like negative 3, then what happens is the inside of the f of x just becomes f of 3. So actually, what happens is, if you put negative values in for f of absolute value of x, it just goes and grabs the value from the positive side of f of x. So actually it ends up reflecting about the y-axis. Everything that's on the right side, it reflects it to the left side. So the way you graph this function here is you discard the graph for x is less than 0, because all those values are just going to map to the y values for the x positive values. And then you're going to reflect the graph for x is greater than 0 in the y-axis. And then points on the y-axis themselves are invariant. Okay? What about when you have y equals the absolute value of f of x? Okay, when you do that, pretty much any value that comes out of the absolute value function that's negative goes to its corresponding positive value. So you keep the graph for y is greater than 0 because it's not affected by the absolute value. And then you reflect the graph for y is less than 0 in the x-axis. So anything that's below the x-axis gets reflected up into the y-axis, and points on the x-axis Even if you reflect them, they stay in the same place, so they're invariant. Okay, so let's do an exercise. Number 1, draw y equals x times x plus 2, and on the same set of axes graph these two versions of the function using the absolute value function to transform them. So first we're going to draw x times x plus 2. Remember that since it gives it to you in factored form, it's easier just to go with that and then graph out like where it intersects the x-axis, which is the thing that the factored form gives you. The 2 points where it hits the x-axis when it's x times x plus 2 would be the zeros, which would be 0 and negative 2. So it would intersect the x-axis at these 2 points. We know that this is a parabola because we could multiply it out and we'll get x squared plus 2x. It looks like a quadratic, right? You know that it opens up because x squared has an a value of positive 1. And we also know, since the a value is 1, that it follows the proportions of a parent function parabola, which is 1, 1, 2, 4, and 3, 9. Okay, so it looks pretty much like that. Okay, oops. Yeah, so it goes through there, and there's the vertex right there. And so first we're going to draw this, the absolute value of the y of the output. So like for example, that would take any part of the function that has a negative f of x or negative y value, which is like anything down here, and it would reflect that part of it above the x-axis, right? So basically you would have, maybe what I'll do is I'll use the highlighter. And I'll use kind of a thin highlighter. Okay. So I'll highlight the part that stays the same. That's not a very thin highlighter. And then it'll like curve up like that, and then it'll go up, you see? So like the part that goes below the y-axis would reflect, or the x-axis would reflect up so that it was above the x-axis. So that's the blue one there. Okay. Let's look at this one here. So if we put in the absolute value sign inside the parentheses, what that does is it takes any negative inputs and it just immediately maps the negative input to a positive input. So like for example, f of negative 3 would become f of 3. F of negative 5 would become f of 5. So basically what it does is it throws away the left side of the graph, and it just takes the right side values and it reflects them over to the left side. So like for example, this would stay the same, this would stay the same. These values would stay the same because they are positive x values. But all the negative value x values would simply just grab the values from across the y-axis. Okay, so that's what you would get for B.